All right, so now we have features. So that's kind of cool. That's neat, and that's useful for a variety of different algorithms as a good base to start with. All right, so let's comment that out, and let's do another useful thing called background subtraction. So what we can do there is we need to have a background subtractor. So luckily, OpenCV has a background subtractor built in that we can use. Okay. So basically, okay. So let's do it here, and let's call p back sub. Just give it a name. Apply. We'll define what this is in a moment. Okay. So we need to have. We'll have to define this. We're going to say apply the background subtraction to our image, our input image, and to our resulting image. We're going to need to make sure we have one of those first. Oops, copy, just like we did before. Oh, not clone. All right. All right. So let's do a background subtraction. Okay, so we need to have this. We need to define this and how to initialize it appropriately. We do that. We could do that just in our main function here, right? Okay. Okay. All right. Let's do it here. Need a background subtractor. Okay, so I need a pointer, a smart pointer to a background subtractor. We're going to call that pback sub, right? Okay, so this is how we initialize a background subtractor. So there are different types of background subtractors in OpenCV. We can say pback sub equals create background subtractor, and there's different types. Let's do, these are just for different algorithms, right? So here, MOG2, and that's it. So let's see. What does that do? These are just different algorithms for how it determines what a background is. Some work better than others in other situations. And, oh, we probably have to draw it, right? Okay. We need to draw the result. Frame 2 and G sub. All right. Background subtraction. Let's see what happens. Oh, look at that. And sure enough, that's kind of cool. So notice that it is activating. It's only giving me pixels in places that change occurs, right? And so if it stays there for a while, it sort of gets rid of it. And then if a change occurs, it sort of highlights, hey, look, something happened there, right? And so then you could think of a way to feed that into good features to track, etc., or erosion, dilation, and then it tries to keep track of this model. So if you, that's why it sort of looks weird, but if you threshold and the image, if you dilate, erode it, you can fill in a lot of these gaps. So let's try a different one. There's another one called NN. I think it's NN. No. Trapdoor. What kind is it? KNN, right. this and see. Similar, a little bit different behavior. And you could, I believe that there are various parameters you can tweak with any of these. Right, I think this one works probably the best. Yeah, so that's pretty cool. And then you'd use that to you can use that as a mask to extract pieces of that, like extract objects and then track those objects afterwards, etc. So that's cool. All right, next video.